quality assurance. He has developed and present programs, practical programs to equip engineers, technicians, inspectors with the critical knowledge and application of pressure vessels design and fitness for service standards. Daniel's SAIMechE membership and participation in the boiler and pressure vessels code committees helps translate the background to many of the code's rules and enables advanced knowledge of code's changes. His qualification, he's got a BSc, Mechanical Engineering and MSc from the University of KZN. He is a registered professional engineer in South Africa with Engineering Council of South Africa. He's also registered professional engineer in Texas, USA. Lastly, Daniel has got 23 years experience in petrochemical industry and as a professional engineer. Ladies and gentlemen, I will now hand over to Daniel to take us through the presentation, and we will interact with him after or during the presentation. Those who prefer to ask the question after the presentation, please jot it down, and then we can engage on Q&A session after his presentation or even during his presentation if you're going to leave early. Thanks. Daniel, over to you, sir.
Okay, thank you very much, Fani, and welcome to everybody on this call. It really is a privilege to be able to share some knowledge and insights with you regarding pressure vessels. One of the reasons we're doing this presentation is that the SAIMechE code, to which most pressure vessels are designed around the world, has changed certain requirements regarding the responsibilities of design professionals. And if you're working in that space, then you should be aware of some things. Actually, you should already be aware of it because the code change happened in July of 2021. There is some impact to the local industry, and we've been trying to decipher that and also represent our mechanical engineers to the Department of Labor with certain proposals, and we'll speak about that through the presentation as well. So really good to see everybody on the call. I even recognize some names there from people that I worked with in the past. So really great to be in touch with such a large number of mechanical engineers in South Africa. And I think I want to start off just to help me frame where I should focus the presentation today. I'd just like to get an idea of who in this call has some kind of experience with pressure equipment design. If you could just raise your hand, I just want to get a feeling as to, at what level to pitch the presentation. I'm just going to take a look at my screen to see more or less. Okay. All right, great. So I will share my screen. Thank you, everyone. You may lower your hands. And I trust that you can see my screen now. All right, so what I have prepared to present to you is also some background on the pressure equipment regulations and where they fit in. I see we will spend a little bit of time there because I see that some of you don't have that experience of pressure equipment design. The pressure equipment regulations in South Africa is part of the Occupational Health and Safety Act. And any equipment that is designed needs to conform in South Africa. To operate pressure equipment in South Africa, you need to conform to the regulations. Of course, pressure equipment regulations is what you need to be concerned about. And the PER also links to one of the SAN standards, SANS 347. I'll tell you very briefly what those standards cover. We will speak about the manufacturer's legal responsibilities, the user's responsibilities, and also something to note, if you're importing equipment, there are some important accountabilities that you take on the moment you become the importer. So we'll speak briefly about that. So one of the main reasons for the presentation, of course, is to take you through some of the major changes in the SAIMechE Section 8 pressure vessel code and how that affects the qualification of design professionals and how your responsibilities would be affected there. I would also speak to you when we're speaking about the code changes about a representation that we're making to the Department of Labor. So just to give you some background, the pressure equipment regulations in South Africa is developed by the Department of Employment and Labor. And they have a forum in which they consult the industry for comments on that. And they take recommendations from the industry as to what should be in the regulations and what might be affecting the industry. And SAIMechE has representation in that pressure equipment forum, and that is actually me. So SAIMechE has nominated me to represent all of you in that. And so you do have representation there. And I suppose this presentation today also kind of gives you an introduction to the fact that if you have questions or recommendations regarding those regulations, firstly, you can contact the Department of Labor directly. You can also comment on their drafts that they issue. But if you'd like us to address something as an industry, then of course, contact me and we can represent that to that forum for you. All right, so pressure equipment does not just cover pressure vessels. There's also some responsibilities for piping design. And I'll speak very quickly about those in ASME B31.3. And then in 2025, ASME Section 8 Division 1 is going to go through a reshape. Actually, the reshape effort is happening right now. I participate actually in most ASME development committee meetings. And so I'll be able to share with you today some things that you should be expecting, especially for those of you involved in the fabrication industry or engineering consulting industry, or you work for operators that have pressure equipment in your plants. You just need to take note of some of the changes that are coming, because it does affect the way we'll be doing business going forward. All right, so I thought before we get stuck into the standard, I'll just tell you one of the reasons that we want to be paying attention to pressure equipment and why engineers need to work together. Engineers from different disciplines need to work together in our plants to ensure safety. So there's a case study that I've had. I do help to resolve certain industry issues sometimes regarding safety. So what we had in this case study was a pressurized system on the right-hand side of the screen there. It doesn't matter what it is really. It is just a pressurized system. And every pressurized system needs to have pressure protection, overpressure protection. If the pressure goes above design, you want a relief valve to open. When that relief valve opens, you would vent to something. If it is a product that can be vented to the atmosphere, it will be vented to atmosphere. And you can imagine that when that relief valve opens, at this bend, there would be substantial forces induced by internal pressure. And you will have a pressure drop over that pipe, obviously, because you are going from a high pressure system to atmosphere. And in this particular system of this case study, the equivalent pressure in that system was, similar to having 207 fire hoses, or the pressure inside 207 fire hoses. That's the magnitude of the force that would have had to be sustained in that area. Well, I suppose the number of firemen that you get to hold a hose times 207 is the personnel that you needed on site for that. But of course, that force is sustained by a structure. And unfortunately, what happened in this instance is that that structure that needed to support that force was substantially under-designed. Why? Well, because the force calculation was not accurate. And so, generally the force calculation for such a system, there are some industry standards to calculate too. If you have a change in phase of the flow, et cetera, when you have the depressurization, you may have to get a bit more complex in terms of the type of analysis that you do. We may have to do CFD analysis, but this is where you could have process engineers interacting with vessel engineers, interacting with piping engineers, and of course, interacting with structural engineers who design the steel support structures. We did find in this case that the whole design of that structure was approved by a structural professional engineer. However, the verification process within that company, usually an engineering contractor has someone that performs the design, reviews the design, approves the design. So at least there's 2 or 3 people involved within the company, and often there's a third-party review as well. None of those processes picked up the error. And what happened was what you see in those pictures, basically the piping ripped apart. There was flammable product actually in the atmosphere, because in between the vent, there was a special emergency relief system that removed the flammable product from the system. And anyway, in this case, we had a large explosion, a local fire. Thankfully, nobody was injured, but you can see effectively what happened to the piping there and the support structure that landed about half a kilometer away from where the plant was situated. So when the design review was done of that plant, we actually found that that same engineering contractor made the same mistake on other plants. They just had not had pressure relief to the extent that this plant had. And, you know, a very important lesson there for engineers to work together when it comes to pressurized systems. All right, so let's get stuck into some of the requirements of the pressure equipment regulations. Firstly, what are classified as pressure equipment? Obviously, pressure vessels and steam generators. Steam generators, also referred to as boilers. Piping systems are also pressure equipment. Pressure and safety accessories are included in the definition of pressure equipment in our regulations. And they do include heat exchangers, fired heaters, storage vessels, transportable bulk and containers, fire extinguishers, and accumulators. In general, if your equipment has a design pressure greater than 50 kPa, it's going to be changed to well, currently it's greater than equal to 50 kPa. In the future, it will be changed to greater than 50 kPa. If you have a pressure greater than that value, then you effectively have a pressure vessel. It does exclude certain things like engines that have a different primary purpose. Hot water geysers smaller than 450 liters are not considered pressure equipment. You don't have to be concerned about the geysers in your homes. And then pressure equipment or equipment that's under external pressure or vacuum conditions only are excluded from these definitions. Effectively, those are the types of equipment, anything with an internal pressure greater than 50 kPa, and if it's not specifically excluded. There are some more exclusions. I just highlighted the major ones here. But those are the things that are classified as pressure equipment. Why are we concerned about pressure equipment? Well, the case study we discussed earlier is one of them. But we want to avoid failure mechanisms such as tensile rupture. You can see that in this picture where equipment there was substantially overpressurized and you have a tensile rupture. Fortunately, this was not something I was ever near, but you know, compressive or buckling failure under compressive stress is also something we want to avoid. A nice picture there of a brittle fracture where equipment was embrittled during service due to service conditions. And when it was shut down for maintenance, it was, they did a pressure test on it and the metal had embrittled such that the pressure test caused this type of failure. It's, you know, very clean type of brittle fracture, completely irreparable kind of thing. We want to avoid that, and pressure vessel codes do have rules to help you avoid that. In-service cracking, if you have things like stress corrosion cracking on pressurized equipment, you could have a progression of cracking over time, and you want to avoid those things. Metal loss, relatively easy to understand, corrosion or erosion. And then we want to avoid manufacturing defects and any kind of leakage, you know, even in flange joints. We want to regulate pressure equipment so that we don't expose the public to dangerous product effectively. Not just the public, also the environment. All right, so where do the pressure equipment regulations fit in? They are part of the Occupational Health and Safety Act. So for those of you who have the OSH Act book in your office, you will find Regulation 17, which is the pressure equipment regulations in South Africa. Pressure equipment regulation does act together with SANS 347. SANS 347 is referenced by the PER, so it becomes part of the law effectively. What do these two things cover? Well, the PER covers the main regulation. It contains the scope of what is classified as a pressure vessel, where these rules apply and where they don't apply. It does have the main responsibilities and duties of users, manufacturers, importers, and the third party, the Approved Inspection Authority, or AIA. It does cover new manufacture, maintenance, and inspection. And the PER, importantly, it requires compliance to a health and safety standard. So the PER, the regulations in South Africa, they do not give you rules as to how to calculate the required thickness of a pressure vessel. That you would get from the health and safety standard. How to weld it, what materials are allowed and what are not allowed. Those are contained in the pressure vessel code or the health and safety standard. In SANS 347, what that standard does is it classifies equipment based on the fluid type, the pressure, and the size. And based on that classification, it has certain requirements for what it calls conformity assessment. If your vessel is considered more critical based on the fluid, the pressure, and the size, then you would have to perform more verifications on it. It's effectively the purpose of SANS 347. It's a conformity assessment document, and whether your manufacturer has an approved quality system or not depends on the amount of, determines the amount of inspections that are performed by a third party. It also deals with certification of the equipment, and there is an allowance in SANS 347 for ASME equipment to be manufactured in South Africa without ASME stamping. And for those of you who are familiar with ordering or designing pressure equipment, you know exactly what we're talking about, that OSHA CI marking that is allowed by the regulations for local vessels. All right, so importantly, SANS 347 does require professionally registered persons to be involved in the designs of category 2, 3, and 4 equipment. Now, the categories are category 1, 2, 3, and 4. Below category 1 is something they call sound engineering practice, where if something is considered really not critical at all, you know, the fluid it contains is non-dangerous, it's very small, pressures are low, you may actually manufacture it in accordance with sound engineering practice rather than a health and safety standard. But for category 2 equipment and higher, where most industry equipment actually is classified, in such a case, you need the involvement of a professionally registered person to comply with the local regulations. All right, so I said earlier that the PER doesn't have the rules for your calculations. You need to go to a health and safety standard for that. There's several around the world, and the most common, still the most common around the world is ASME, American Society of Mechanical Engineers. It has several codes, you know, section 1 for boilers, section 8 is pressure vessels that we're going to focus a bit on today. You know, the law in South Africa does allow you to design to other standards as well. All right, so ultimately, regulatory compliance does imply you have to comply to the code. So if you have an ASME stamped vessel in South Africa, it needs to conform to ASME. And if it does, then it conforms to the South African regulation, provided all the other requirements of the regulations are met, right? Okay, so let's spend a little bit of time speaking about manufacturers' responsibilities. And I think this is quite important to cover because it's actually one of the reasons for the way the pressure equipment regulations are structured here. The manufacturer, as defined in the PER, must have or must hold overall accountability, overall control for the design, fabrication, testing, and certification. So whenever you appoint a manufacturer to provide you with pressure equipment, you should ensure that they are capable of taking on those accountabilities. There are cases where a design contractor or a engineering contractor, even a user, might perform the design themselves and appoint a contractor to manufacture in accordance with that design. When you do that, you have to determine who has overall control of that process. And if it is the user or the design contractor that has that overall control, they would be deemed to be the manufacturer. There is some legal accountability that goes together with that. So one of the responsibilities of the manufacturer is that the manufacturer needs to ensure that the equipment is safe and without risks to health when it is properly used. The user must use it in accordance with the design conditions. However, the manufacturer should ensure that it is safe and without risks when it is operated under those conditions. And it is a simple statement to make, but there's a lot of accountability that goes with that. And therefore, you need to always ensure that the manufacturer is capable of taking on that accountability. So the manufacturer must perform the work in accordance with the law, including the code, which is incorporated into the law by reference. The manufacturer must also appoint an accredited third-party inspection agency to oversee the work. Actually, the user can appoint such a party as well, but there must be a third party appointed. And in South Africa, we call that the Approved Inspection Authority, or AIA. And if you're importing equipment, if it's ASME equipment, it'll be an ASME authorized inspector that is a third party. And for equipment imported from Europe that is CE marked, you would have a notified body that is the third party. And then the manufacturer must also issue a certificate of compliance that is countersigned by the third party. All right, one of the responsibilities of a manufacturer is after they release the vessel, if they find defects in it, you need to report that to the user, and together with the user determine some kind of rectification plan. All right, so sometimes things go wrong with the manufacturer's responsibility, and I wanted to share this experience with you because this did happen on equipment where, you know, the engineering contractor expected the manufacturer to comply, and in the same way, all of us in the industry order equipment expecting manufacturers to comply. And there's certain things that you just do not see, but things do go wrong. So what happened with this particular column? Half of it was being replaced, right? It was going to be cut actually towards the bottom, and an engineering contractor was going to take that away and bring in a new piece to replace the top section of the column that had undergone some kind of corrosion. So the engineering contractor ordered this top piece of the column from a local manufacturer. That manufacturer, manufactured it, pressure tested it, sent it to site, and it was being installed in the equipment. And while it was being installed, there was an anonymous whistleblower that contacted one of the plant managers and said, there's some defects in the weld that were not properly repaired, and the equipment was released in that condition. And to give you a quick explanation as to what the defect was, so if you look through the wall thickness of this steel, the base material is a high strength steel, and all the strength comes from that. What I've shown here is a weld equipment, or the wall was welded from both sides. And on the inside was a low strength corrosion resistant cladding. Common type of arrangement we have where we need the corrosion resistance on the inside. It's expensive material, and you use the high strength material effectively to carry your design load. And what the manufacturer did is, after they had applied that cladding, they found that there were a lot of defects in the weld below. So they excavated that weld. That's okay to excavate the weld, but after you do that, you need to fill it up with high strength material, because your design thickness is dependent on that strength, right? However, what they did is they filled up the entire weld with low strength cladding, and effectively the material that we had to carry the load was less than 1/3 of the required thickness, or of that original design thickness. So these things do happen in industry. Of course, a lot of repairs had to be done. I guess we can call it a fraudulent manufacturer, worker incompetence, quality systems are not followed, a whole host of things went wrong. And unfortunately, this does happen in the industry. And you never know when a good manufacturer might stop being good like you knew them to be. And I wanted to highlight that we'll speak a little bit later about importers' responsibilities, but I think it is important to note that although the law doesn't require the user to perform any kind of quality management, it requires only the third party to do that. But it is in the user's interest to perform some kind of quality management on pressure equipment while it's being manufactured, especially those critical ones. All right, so the user's responsibility in terms of the law are to provide comprehensive information to perform the design. The manufacturer cannot perform the design unless you provide him with that comprehensive information, operating parameters, services that can cause degradation, environmental conditions, etc. The user must also ensure that there is certification by a manufacturer and a third party. You must have that certificate of manufacture, and that the equipment is pressure tested after installation. The user also provides overpressure protection in many cases, and the user is involved with things like HAZOPs to determine that the equipment is protected against maloperation, blockages, runaway reactions, that kind of thing. So that's during the design and procurement phase of a project. But some of you are operating equipment. The pressure equipment regulations require, in that case, that users must inspect and test pressure vessels and steam generators every 36 months. You may replace that with a risk-based inspection program. There's some additional provisions and exceptions, but that's effectively one of the main requirements of an operator. If you perform any repairs or modifications, you need to appoint a manufacturer or repairer or modifier that will take responsibility for that and effectively implement all of the other regulation requirements and code requirements during that repair or modification. There's something else that happens in service equipment, and that's what we call fitness for service assessments. So sometimes there could have been, let's say, localized corrosion on equipment, and you determine through advanced analysis that it may operate. There are actually fitness for service standards out there in service inspection codes that refer to fitness for service industry practices that you can use to qualify your equipment. The OSH Act also allows this, the PER allows it. And in some cases, I've found that users don't get that design for fitness for service assessments verified by a third party. This is something for you to note. The law does require that, must be verified by a third party. All right, that's as far as users' responsibilities go, the summary thereof in the PER. The importer does have responsibilities specifically mentioned in the regulations. The importer assumes the liability of the manufacturer in terms of the pressure equipment regulations. What this means is all those responsibilities that we saw earlier of the manufacturer, for example, ensuring that the equipment is safe to use and without risks, etc. All of those responsibilities fall on the importer of the equipment. What that means, of course, is if the equipment fails, the importer will have to answer. And the reason the PER states that is that the law or the regulators want to have a juristic person in South Africa to go to if something goes wrong on your facility. So when you are importing equipment, you need to be prepared to take on that accountability. How do you do that? Well, you perform a conformity assessment review. You'd also have to appoint an AIA, approved inspection authority in South Africa, to review that conformity assessment. And I've just put in some notes here as to what we recommend actually when you're taking on that accountability of the importer for such equipment, that you appoint only dependable manufacturers. You perform 100% document verifications, as at least document verifications. You align on all technical requirements, including frequently omitted code requirements with the company that's manufacturing equipment for you, that's located outside of South Africa. You also perform critical physical inspections. Go to those manufacturers for critical equipment and arrange for frequent inspections on those critical aspects. Appoint local independent inspectors when that makes sense. Sometimes you can't be there all the time, but you can get a third party and appoint an inspector in whichever location around the world. And also consider random checks, sometimes which the manufacturer might not expect. I've done that on several occasions, like we had critical equipment in India, and I would pitch up at the manufacturer during the night shift, make arrangements to get to the site with the third party that we had there, and just go there and ensure that they are following procedures even at night, because that's when things sometimes go wrong. All right, so those are responsibilities of the importer and some recommendations as to how you can mitigate some of the risks you face when you take on those accountabilities. And as professional engineers, let's do the right thing and ensure that we don't just rubber stamp importer conformity assessments, but that we have some level of confidence, especially when we have critical equipment. All right. I've listed here some of the common pressure equipment health and safety standards. Under ASME, Section 8 pressure vessels is what we're talking about today, and the responsibilities of design engineers there. There's Section 1 for boilers. There's several other sections, by the way. Process piping is covered in B31.3. Now, Section 8 and B31.3 are the two common codes that actually refer to qualifications and experience requirements for designers. And this is the reason I've put them in bold, and we're going to speak about that. I've listed the other standards there that are you might be familiar with. They don't have specific requirements for designers, but these ones do, and we're going to speak about that today. All right, so the pressure vessel code does have some very important changes that we wanted to highlight to you. Firstly, in the past, Section 8 Division 1 never required a confirmation of design information from users, but it does now. Since the 2021 changes, it does require that. There is also a specific requirement for software verification of design calculations. And there's another change regarding the qualifications and experience of designers. So actually it breaks it down into three classifications. One is designers, one is engineers. Designers and engineers have effectively the same amount of design authority, but depending on their qualifications, they may be called designers or engineers and require a certain amount or a different amount of experience depending on the qualification. Then there's the aspect of certifying engineers. There are some aspects of design that may only be performed by what the code refers to as certifying engineers. And unfortunately, the ASME code does not recognize EXA registered professional engineers as certifying engineers. You need to have something else, but we'll speak about that as well. Okay, so on that first change, why did the code introduce that? So firstly, there were issues with users failing to stipulate all design conditions. And then the manufacturers assumed that there is no such design condition to take care of, and therefore the equipment is not designed for those conditions. So now there has to be some kind of approval of that. So in summary, there's some new clauses in the code that require a user's design requirements form or something equivalent to that to be completed. The manufacturer must then state that he has conformed to all conditions that are stated by the user. And then there is something added here, which is that the manufacturers are responsible for not just the pressure integrity, but also the structural integrity of equipment. That's what ASME says now. There's some extractions that I pulled out here. I've got the reference in the title for those of you who do work with these codes. It is in U2. And the user's design requirements form must be filled in if you have any of these conditions. We found that this does apply basically to all vessels because you always have some reactions, for example, from piping, you always have wind loads or seismic reactions to take care of. And so under those conditions, you need to have this user's design requirements form that is approved by the user. And again, the manufacturer is responsible for the structural and pressure retaining integrity of the vessel. Important change there for design engineers to take note of. All right, then the code also in Appendix 10, it requires that you do verification of the software. So what has been found in industry, and I found this myself when auditing manufacturers, is that manufacturers use software and in-house spreadsheets that have errors in them and were never properly verified, or revision control is not properly managed. And so sometimes the software is just never validated at all, those calculation spreadsheets. Actually, sometimes I've asked manufacturers to what they perform the calculation, and instead of saying they perform it to the SAIMechE code, they say they perform it using PV Elite, for example, which is one of the pressure vessel software packages out there. So the code now requires that all manufacturers must have a quality system that addresses the verification of software. I've just pasted some of the wording from the code here. Prepared calculations or analysis must be verified as follows. It is verified to show that it produces correct solutions for the encoded mathematical model within the defined limits of each parameter employed. And then that also the mathematical model shall be verified to show that it produces correct solutions to the physical problem. Some onerous requirements there for the manufacturer to ensure that the software is using is verified. And I always ask manufacturers for their verification when I perform an audit. Therefore, if you are involved with supporting a manufacturer, you work for a manufacturer, or you're ordering from manufacturers, you should ensure that this is in place by the manufacturer. The good manufacturers that I audit, if I ask them for the verification of their software, they pull out a file that shows the revision and the version of the software that they are using. It corresponds to the software that's installed. And they also have run several cases of pressure vessel designs where the software results are verified. And they have that filed for every update of the software that is installed on their systems. Something that manufacturers need to now officially take care of. All right, and then another major change is the requirement for designers to meet a certain minimum standard. And so there was a concern in the industry that many designers were not really sufficiently knowledgeable or experienced with applying the code requirements. And therefore, there's been some changes. The summary thereof is that designers, engineers, and certifying engineers must meet certain minimum qualifications and experience, and the manufacturer must ensure adequate qualifications and experience of those performing the design. You can, if you're ordering equipment from a pressure vessel manufacturer, you can ask them to prove to you that they have met those requirements. All right, so one of the things I do want to speak to you about is this phrase, responsible charge. The code requires that a designer, engineer, or certifying engineer designated by the manufacturer shall be in responsible charge of the design of a pressure vessel. And then the person that is in responsible charge of design activities shall be experienced, and the qualifications and experience required by the person in responsible charge does depend on the complexity of the equipment, and we will see that later. So this is a very nice term to use, that the responsible engineer needs to be in responsible charge. It is an industry term, actually, but the SAIMechE code does reference a definition for that. And that reference is to the American National Society of Professional Engineers that has a position statement on what responsible charge means. I'm just going to read the red bit here that says, a professional engineer in responsible charge is actively engaged in the engineering process from conception to completion. Engineering decisions must be personally made by the professional engineer or by others over which the professional engineer provides supervisory direction and control authority. Reviewing drawings or documents after preparation without involvement in the design and development process does not satisfy the definition of responsible charge. So this practice of having a professional engineer review your drawings and design at the end without any involvement at the beginning does not satisfy this requirement of responsible charge. And for some companies, I know this requires a change in the way of working. So we do need to take note of that. All right, so I did mention to you that the code currently does not recognize as certifying engineers. So certifying engineers aren't always required, but when a certifying engineer is required, an XR registered engineer is not accepted by default or not recognized by default. I've just put on this page some of the different types of registrations that they are and the experience that one would have to have when being recognized by SAIMechE as a certifying engineer. So in the USA, there's several requirements. There's actually 2 exams to be written, the PE exam being the last one that qualifies a person to be registered as a certifying engineer or recognized. In Canada, it's 4 years experience in addition to the bachelor's degree, but you also write a professional practice exam. And then there's the international register. International register requires a bachelor's degree, and it requires 7 years of experience. And 2 of those years needs to requires that you are in responsible charge or fulfilling that kind of role. If you are an XR registered engineer, you meet those other requirements, you can register to be on the international register. It is not automatic. It is a separate application that you need to make. You pay a certain fee, I think, initially, and you get onto that register after you go through that application process. And if you are on that register, then you would be recognized by SAIMechE as a certifying engineer. Asia Pacific, those engineers have to go through the same pain. And in Europe, although the different countries in Europe, I was at an Italian manufacturer recently and German manufacturer, and we've been asking manufacturers as to how they're dealing with this, and they all have to go through a similar pain as well, because to be part of that FIANI federation, effectively, they need to have a separate registration than what those countries require locally. This does require 3 to 4 years experience in Europe. So everything within the red block there is what the code recognizes as certifying engineers. So in the cases where a certifying engineer is required by the code, you need to meet one of those requirements there. You all know, I think by now, that XR does require you to have at least 3 years experience, I think. And but that is outside of the red block. So individual countries, even in Europe and in Asia Pacific, are having to go through this pain of being recognized in that way. All right, so for those of you who are familiar with SAIMechE Section 8 Division 1 and Division 2, I've highlighted for you here where you would have difficulty. That is where a certifying engineer would be required. And that's everything that is in red on the slide. I'll describe the slide to you and go through it slowly in a moment. But, initially, I think some parts of the industry reacted unfavorably towards those requirements because they thought they had to get certifying engineers to certify all designs, and that's not the case for Division 1, which is the most common code. Section 8 Division 2 is a code with a lower safety factor, and it gives you thinner vessels, but it requires more inspections and more rigorous design. And because of that approach, it does require professional engineer involvement or certifying engineer involvement for more of those types of designs. All right, so if an engineer has a 4-year degree and 4 years of experience, then you are recognized as an engineer in terms of the code requirements for performing designs, right? But if you have any other technical tertiary education plus 6 years experience, you are recognized as a designer. So engineering technologists, of course, would qualify for that as well. The code also allows people without a formal technical tertiary education to be recognized as design engineers if you have 10 years of design experience. Division 1 does recognize that. However, do note that our law that we discussed earlier, it requires for category 2 equipment and higher that you need to be a professionally registered person. So our law actually is superior in some respects to these designations. So if you have that experience, you can basically be in responsible charge of Section 8 Division 1 work, except for some special designs that are mentioned in the rows below. For Section 8 Division 2, you would have to have that certifying engineer qualification to handle some of those special designs: fatigue analysis, quick actuating closures, dynamic SAIMechE analysis. And in Section 8 Division 2, there's 2 classes of equipment. The more critical class of equipment, that design cannot be certified unless you are a certifying engineer. All right, and so there are some special designs where you require some advanced knowledge. So the code says, in addition to having those requirements as designer or engineer, you also need to have 2 years of experience with dynamic or SAIMechE design if you're doing those types of calculations. Same applies for designs not addressed in Section 8 Division 1. Numerical analysis, which is effectively mainly done by finite element analysis. You may also do that without being a certifying engineer if you meet the requirements of engineer or designer, plus you have 2 years of experience with it, and you have proof of accredited training in that type of analysis. If you meet that, then you may perform Section 8 Division 1 designs, excluding fatigue analysis. There you do need a certifying engineer to authorize the design. And for quick actuating closures, also a special type of design, you need some extra experience. With heat exchangers for Section 8 Division 2, that's where you need some additional experience as well. It kind of summarizes where a certifying engineer must be involved according to the code, and where we would have difficulty meeting that requirement unless the organization has somebody that is qualified as indicated within this red box. And that is, for example, if you're EXA registered, you need to go through that additional registration and be on the international register. All right, so a certifying engineer, if you are a certifying engineer, you can perform all designs in Section 8 Division 1, and you can also perform all designs in Section 8 Division 2, except that you also, for Division 2, you also need to have a written testament of compliance to the ASME Code of Ethics. And with that in place, you can certify all designs. And that is really not very different from the Code of Ethics that you subscribe to when you register as a professional engineer anyway. All right. These red areas here do present a little bit of a problem for us in South Africa. And I mentioned to you earlier that SANS 347 has a section where it allows equipment to be manufactured in accordance with the ASME in South Africa, although it is not stamped ASME, and we use local third parties, etc. So it has certain requirements that you need to meet, and it allows those vessels in South Africa, and they are stamped instead of ASME, they're stamped OSHA, they're OSHA stamped effectively. So we've made it, we've represented this position to the Department of Employment and Labor. And we've proposed to them that that section that allows you to have ASME equipment in South Africa, we've proposed to the Department of Labor that they allow us to have certifying engineers, wherever the code requires a certifying engineer, that EXA registered professional engineers with 7 or more years of experience would be allowed to sign off as certifying engineer. That's a representation we've made. I actually chaired a little subcommittee for the Pressure Equipment Regulations Forum, and everybody basically unanimously agreed with this type of proposal to the department. And hopefully SANS 347 will be updated in this way. Unfortunately, it is not the case right now. and you have to still comply with the code until this change is effected. That's one of the things we did. Of course, I took this proposal through the SAIMechE Exco, and that was fully supported there. All right, I think some of you might have some questions on that, and we'll take it after a few more slides. Because we're speaking pressure equipment, we've spoken mainly pressure vessels. I know there might be some piping engineers here. I wanted to highlight to you that if you're designing process piping in accordance with B31.3, there are some requirements for design engineers there, but it is not as solid a requirement as Section 8, because the piping code allows the owner to waive the requirements here. So unless the owner's approval is required if the individual does not meet at least one of the following. In general, you want to comply with this, right? And so this is a completion of a degree accredited by an independent agency, such as, although EXA is not listed here, I'm sure it would be considered adequate here. Professional engineering registration is required. Completion of an accredited engineering technician or associate's degree with a different level of experience, or 15 years of experience if you don't have that tertiary qualification. So this is what the piping code for process piping requires, ASME B31.3, unless the owner waives that requirement. But I do want to highlight to you that we remember that SANS 347 does require professionally registered persons to approve the designs for category 2 equipment and higher. If it is below category 2 equipment, the code still requires a certain qualification, and you should ensure that you meet that unless it is formally waived. I don't think many owners will waive that without due consideration. All right, so the last thing that I wanted to discuss with you is a major change that is happening in the code in 2025. So Section 8 Division 1, like I said, is one of the most common pressure vessel codes applied around the world. But the code has been updating Section 8 Division 2 to incorporate the types of vessels that people go to Division 1 for. Actually, the members of the ASME Code Board would prefer that people move to the ASME Section 8 Division 2. And by introducing some changes, they're kind of forcing that a bit in the industry. So they're encouraging the move from Section 8 Division 1 to Division 2 by the reshape action that's happening in the 2025 edition, or that starts there. So they say they intend to maintain the ASME Section 8 Division 1 brand for a short run until users move to other options. The common rules support in Division 1 for Division 1 users is actually moving to Division 2. So what they're doing is Section 8 Division 1 has design by rule, a design by rule section. Actually, the whole code is effectively design by rule. Section 8 Division 2 has design by rules and design by analysis. Wherever Section 8 Division 2 has a rule that looks like the Section 8 Division 1 rule is going to be removed from Section 8 Division 1, and the user is referred effectively to Section 8 Division 2. And they feel that that will also reduce the workload and volunteers, because at the moment, when code sections are updated, they've got to update the two codes. There's some clarity that will be provided through the rewrite, because the way the code was updated over the last 20 years or so, it does leave it a little bit untidy. Half the requirements are in one section and other requirements are in another section. It doesn't read very nicely anymore. So that's going to be corrected. And then they intend to have a longer revision cycle for Section 8 Division 1. So basically it'll go into like maintenance mode. Division 2 is the code that they hope users would move to. Section 8 Division 1 will contain rules for simple pressure vessels. And excuse me, the Division 1 accreditation would also move to ASME Section CA1. So what does this mean for the industry? I think if you're involved in the manufacturing industry or engineering consulting industry, you've got to look at moving to Section 8 Division 2 construction. And when you do that, you would be able to to satisfy users' needs as users start moving to that type of design code. There's something to keep in mind for your development going forward, and ensure that you have the quality systems to support Section 8 Division 2 work, not just Division 1. Quality systems and the manufacturing procedures, of course. All right, that brings me to the end of my presentation. And I think I'm handing over to Portia to facilitate the questions.
Hi, thanks, Daniel. Good evening, everyone. I hope you guys enjoyed that presentation. Could you please just raise your hands for questions, and we will run through first come, first serve basis. Okay, so Cleo's iPhone is first. Cleo, may you please unmute yourself and ask your question?
I would like to ask, in terms of the API 579, the fitness for service roads, which lend methods from the Section 5 of Division 2, does the same certifying engineer rules apply? And if not, is there movement in the industry that API is also maybe heading this direction?
Okay, very good question. So if you have in-service equipment, you may perform advanced assessments on it using API 579, which is a fitness for service standard. If you're using the rules of 579, you should have a qualified engineer. My recommendation is always to have similar qualifications as the original code requires. If you're performing advanced assessments like finite element analysis, I would always recommend that you have those requirements. It is not explicitly listed or stated in SAIMechE FFS1 or API 579 that you must have those requirements. Maybe it will be included in that standard in the future. Those minimum qualifications of designers is not there currently. So you will be compliant if you don't meet those requirements, but it is always recommended to meet those minimum qualifications for the reference code. Okay.
Okay, thank you, Daniel. Please do keep your hands raised until I've called you. Elisa, please go ahead.
Hi, how do these qualifications refer to the design and manufacture of valves? Because SANS 347 calls valves as pressure accessories rather than equipment, I think.
Yeah, so the qualifications that we spoke about in terms of the SAIMechE code are only for equipment that is manufactured in accordance with SAIMechE. So for example, pressure safety valves that are SAIMechE stamped need to go through that kind of qualification requirement. But other valves that you would purchase for the piping system, for example, that's certified differently, they are covered by the PER, which means they must meet the PER requirements, but they don't have to meet SAIMechE if they're not certified to that. Okay.
Okay, thank you. I'm just trying to see if there's any other hands. I don't see any other hands. Does anyone else have a question? Okay, Mwegedzi, please go ahead. Mwegedzi, we can't hear you yet. I think Mwegedzi is struggling with his mic. Mwegedzi, maybe you can type the question, and if we can get Daniel to respond to you, maybe on email, that could also work. Are there any questions? Okay, I don't see any more hands. And I don't see any questions in the chat. If there are no more questions, we would like to thank Daniel for taking this time to share with us. As he noted, SAIMechE is trying to participate and ensure that we are represented at the different levels of government structures. So please do contact us and let us know if you'd like us to take up something as an industry. He did say you're welcome to contact him. I would suggest that you send them to the office so that we consolidate and send through any questions and any comments you might have. And from there on, we're always there to try and support the industry. So thank you to Daniel for taking this time, and thank you everybody for attending. Thank you and have a great evening further. Please do remember to complete the attendance register for CPD. EXA will be auditing us. So if you claim CPD and you're not on the register, it will not go through. Please, we do request that. Thank you, Daniel. Thank you, everybody. Have a great evening.
Thank you. Goodbye.
Thank you, everyone. Bye-bye.
Thank you very much. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.